Hi guys, welcome to lesson 21.4, transforming exponential functions. You are going to need your lesson 21.4 note sheet, which is posted on Google Classroom. You'll want a pen or a pencil, and you'll probably want a calculator or desmos.com pulled up. We are first going to be describing the transformations of an exponential function, which should be pretty easy because we have worked with transformations many times before. And then the next thing we're going to do is graph transformations of exponential functions. So let's get started. First up, this page is super important. This is basically where you will find all of your transformations. So the exponential function, this is the parent function that we've talked a little bit about so far. So y equals a times b to the x. But there can be some changes to that function that will transform it. So the first one being this a value, okay? So now if that changes, if it is greater than 1, it's going to be a vertical stretch. So if it's 2, 3, 7, anything like that, it's going to be a vertical stretch. If it's between 0 and 1, like 1/4, 1/3, 0.76, anything like that, it's going to be a vertical shrink. And then if a is negative, it's going to be a reflection over the x-axis. Again, this should sound pretty familiar, okay? Then you have your h value here, and if h is negative, so if it says minus h like that does there, it's going to move to the right because that's what the original problem has. And if it's positive, it's going to move to the left. So remember, that's going to be kind of the opposite way of what we're used to thinking, because normally we think positive to the right, but the original problem has a minus sign in it. So you just have to be careful with that. Okay. And then last, you have the plus k at the end. And that is, if it's positive, it's going to move up. If it's negative, it's going to move down. And that part makes sense. Positive is up, negative is down. Okay. This is a really important piece right here. The k value will also move your horizontal asymptote. So far we've only seen our horizontal asymptote at y equals 0, which is your x-axis. But if your graph moves up or down, then that horizontal asymptote will also move up or down with your graph. Okay, so that's really important. And then last part down there, it says b is the base of your exponential function and does not have any transformations. So notice no transformations there. Okay, that is the base. All right, so let's go ahead and try some of these. So example 1 is just asking you guys to state the transformations, describe the transformations. So first one, we have a 3 out front. So remember, 3 is greater than 1, so that would be a vertical stretch. And vertical stretch of 3. Okay, then we also have, so there's nothing with the x up here. Oh no. Okay. So since there's nothing with that x up there, we are not going to do anything left or right. There's no horizontal transformation. But then there is also this minus 9, so it is going to move down 9 units. And that is it for that one. Remember that 5 is your base, so nothing happens there. Okay. All right, this next one, the negative out front, tells us there's a reflection over the x-axis. Okay, that's helpful. Then this part here tells us, remember, it's opposite of what you think, so plus 3 moves it to the left 3 units. And again, that's the base. Nothing to write about that. Okay. Then this next one, we have a 1/3 out front, so that is going to be a vertical shrink by a factor of 3 or 1/3. Okay, and then we have this here. So that's going to move to the right one. And this here is going to move up 6. And that's it. Again, this part here, not going to change. That's the base. Okay, so I'd like for you guys to go ahead and try this last one here. All righty. Moving right along, we are going to move into graphing exponential functions. So here's what we want to do. We want to be able to draw a rough sketch of the parent function to help us graph the transformations. And we're going to do this by graphing 3 points. So your points, and this math tip is in your Springboard book. This is very important. It says you can draw a quick sketch of the parent graph for any base b by plotting the points -1, 1 over b, 0, 1, and 1, comma b. So as long as you know what the base of your function is, you can come up with 3 points very quickly. Okay, so that being said, our 3 points for if it was 2 to the x, well, the base is 2. So you would do -1, comma 1 over b, so 1 over 2, 0, 1, that one always stays the same, and then 1, comma b, so 1, comma 2. Okay, then same idea here. If it was 1/4 to the x, well, that would be your b, 1/4. So then you would have to do -1, comma 1 over 1/4. Well, 1 over 1/4, if you skip, flip, multiply, that's going to be 1 times 4 over 1. So that is 4. So that's where this one comes in. Then 0, 1, always the same. And then 1, comma b, so 1, comma 1/4. So that's that. Okay, so let's go ahead and try that here. So I usually like to identify my 3 points as like a table. So I like to say, okay, my first one, I know these are always going to be -1, 0, 1. My first one needs to be 1 over my b, and in this case, my b is 1/2. So that's another example where you would skip, flip, multiply, and you would get 2. Okay, then this is always going to be 1, and then this is always going to be your b, so just 1/2. Okay, same idea over here. You can make your table. And I would definitely write these down somewhere, that those are where we're getting the 3 points. And then you have -1, 0, 1. The first one is 1 over b, so 1 over our b value is 4, so 1 over 4. Next one is 1, and then your b value, so just 4. Okay. Now, what we're going to do next is we are actually going to use these 2 parent functions to help us graph transformations. So if we go ahead and look at this next one, hopefully you guys can see here, but I've already plotted those points here in pink, so you can kind of see what the parent function would look like. So in purple, that is y to the 2x, so that y equals 1/2 to the x. So that one we just did on the last page. So I just plotted these 3 points in purple. Okay. So that's what I've done so far. Now, and I'll write that here. The parent function. Now, this one has transformed, so let's look at that. We have a transformation here, a vertical stretch of 2, and we have a transformation here to the right 3. Okay. Let me lock this in place. Sorry about that. Okay. So what we want to do now is we want to, remember that table we had? So it was -1, 2, that's this point here. Then it was 0, 1, that's this point here. And then it was +1, 1/2. That's this point here, okay? So what we want to do, because of this 2 out front, is we want to take all of our y values and multiply them by 2, Okay, so we're going to multiply by 2, and that's going to equal 4. Multiply by 2, and that's going to equal 2. And then multiply by 2, 1/2 times 2 is 1. So now I'm going to plot those points. So -1, 4. -1, 4. 0, 2, and 1, 1. Okay, so this is what it would look like if it were stretched vertically by 2. But we still have, let me erase this actually, we'll use a different color. We still have one more transformation that we need here, and that is that x minus 3. So all of those points that we just did, we need to move to the right 3. So I'm just going to literally go 1, 2, 3. So that's going to be here. Same thing, 1, 2, 3, that's going to be here. Same thing, 1, 2, 3, that's going to be here. And then I have my final graph in red. Okay, so that's the one we want to focus on, the one in red. Okay, and that's what we're going to use to answer these questions over here, because that is the one that has all of the transformations. All right, so first of all, is it increasing or decreasing? Well, as we move from the left to the right, it is decreasing. Okay, then the horizontal asymptote, because this one did not move up or down, there was no plus k at the end here, so there wasn't anything here, plus k. So that means the horizontal asymptote is still going to be at y equals 0, because it didn't move up or down. And that means that there's still not going to be an x-intercept. Okay. The y-intercept for this one is a little bit tricky because you can't actually see it. But what you could do is plug in 0 for the x, and that would help you find it. Or you could always graph this on your graphing calculator or graph it in Desmos. But if I go ahead and just plug in 0 for x, 2 times 1/2 to the 0 minus 3. Okay, so that is going to be 0 minus 3 is -3. 1/2 to the -3 is 8. So 2 times 8 is 16. So that means your y-intercept should be at 0, 16, which makes sense because if we were to keep going this way, it would be somewhere much higher off the graph. Okay, so 0, 16, and then the last thing you have to do is your end behavior. So as always, that is as x approaches negative infinity. So as we move to the left, what's happening? Well, the graph is going up. We saw that with the y-intercept. So it's going towards positive infinity. And then as x approaches positive infinity, or as we move to the right, remember from yesterday that our graph is going to be approaching that asymptote. So it's approaching 0. Okay. All right, and that's it for this one. Let's go ahead and try one more here. Okay, so first thing, again, here's our base. So we already did that. We knew that we should have, sorry, let me lock these. We knew we should have our x values and y values. We knew what those were. -1, 0, 1. And we had, this was at 1/4, 1, 4. So I actually already plotted those in here. You can see those points. So that's what your graph should look like for your parent function. But we have a negative out front, we have x plus 1, and we have that -2. So we are going to have some transformations here. So then the next thing I would do is your reflection. And so literally I just reflected those. So I put like a negative out front of all of them. Okay, all of your y values again. So that's what I have here. -1, -4, -1/4, 0, -1, and 1, -4. So that's this one here. And then what I would do last here is move each of those 3 points to the left 1 and down 2. Okay, so it's very important to know your transformations. So that's what I did. I moved it to the left 1, down 2. So left 1, down 2, if you guys can see that. Same thing, left 1, down 2. Okay, and then left 1, down 2. So this one's actually off the graph a little bit too. It's at -6 here. So this one in blue would be our final answer for this graph. So now we have to answer these questions again. So as we move from left to right, is it increasing or decreasing? It is going downward, so decreasing. In this one, our horizontal asymptote did change. So remember, if it moves up or down, your horizontal asymptote is going to change, and this one moved down 2. So y is at -2. Okay, so if you want, you could kind of draw in a horizontal asymptote there with a dashed line. Okay, but that graph is never going to cross that. So again, we're going to have no x-intercepts. Okay, and again, we're just focusing on the blue, but that one's never going to cross the x-axis. Then our y-intercept, we can see here, it is at, if we kind of continue our y here, our y-intercept is at 0, -6. Oops. And then last, we just have to do our end behavior. All right, so as x approaches -infinity, so to the left, y approaches the asymptote. Well, remember the asymptote now is at -2. And then as x approaches positive infinity, so as we move to the right, y is going down, 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 so y is approaching -infinity. All right, so that is it for today. If you guys have any questions at all, we're going to be practicing this in class tomorrow. Have a good one. Bye-bye.